Chapter 10 is about probability, in which there are sample spaces within our experiments. So I just have three very simple experiments. Maybe if we were rolling a standard die, if we took the sample space of that, it would be 1, 2, 3, 4, 5, 6. If we looked at the sample space of tossing a coin, we could have heads or tails as our sample space. And if we were tossing two coins, for instance, the sample space would be tails and tails, tails and heads, heads and heads, or heads and tails. Next, we're going to look at the fundamental counting principle. If one event can occur in, let's say, m ways, and another event can occur in n ways, then the number of ways that both of the events can occur is going to be m times n. And if there were 3 or more events, then it would be m times n times p, etc. So that would be for 3. So let's look at a sandwich example. You're making a cheese sandwich, and there are 3 types of bread and 2 cheeses. How many different combinations can you make, assuming you're not allowed to mix your cheeses or your bread? So using our counting principle, we said there were 3 types of bread times 2 types of cheeses, so there are going to be 6 ways. And I can represent that using a tree diagram. Now, if I had a lot of different choices, the tree diagram would not be very practical. But this is just a small number, so 6. But again, we have our 3 types of bread. Then we have our Swiss and cheddar matched with our different breads. And our final column shows that we could have white bread with Swiss, white with cheddar, wheat with Swiss, wheat with cheddar. So again, we end up getting our 6 possible types of sandwiches. In this next example, you're going to see that a tree diagram isn't going to be very practical. We're looking at a Texas license plate, and it says that a typical license plate has 1 letter followed by 2 digits followed by 3 letters. So you need to know that there are 26 letters in the alphabet, and when we're looking at our digits, it will be 0 through 9, so that means there are 10 possible digits. So 1 letter would be 26, and then it says we have 2 digits, and we just said that that would be 10 possible that we could choose from. Then it says 3 letters, so that would be 26 times 26 times 26. And when we multiply that all together, we get 45,697,600. But in example B, it says you cannot repeat your letters or your digits. So now we have our first letter is going to be 26 times, and for numbers, we still get to start off with 10, but now, because we've already used one of the digits, it's going to be times 9, and now we're looking at our 3 letters. We've already used 1, so now it's going to be 25 times 24 times 23. And when we multiply those all together, we get 32,292,000 ways. So you can see that tree diagram would not be a good choice. So far we've looked at the counting principle, we've looked at a tree diagram, and we also examined when we're not allowed to repeat, for example, a digit or a letter. On this slide, we're looking at permutations. And the important thing about permutations is that order is going to matter. So there are 6 ways to arrange the letters X, Y, and Z. Here we can see if we begin with the letter X, it can be followed by YZ, or if we begin with the letter X, it's followed by ZY. Next, we decide that we're going to start with the letter Y, followed by XZ, Y, then followed by ZX, etc. So we ended up with 6 ways when we listed them. And again, sometimes we're going to be dealing with values that are so huge, it's not going to make sense to try to list them. So we're going to be using something called factorial. And that's what this says. N exclamation mark means N factorial. So N would be 3, because we had 3 letters. Then we do the 3 minus 1, that would give us the 2. The 3 minus 2, that would give us 1. So 3 times 2 times 1 gives us the 6 ways. I'm going to show you how we can use a calculator. We'll use it for this small example, but the calculator will be best used for larger calculations. All right, we're going to enter 3 factorial into the calculator. So the first thing we're going to do is, because we're using 3 factorial, we type in a 3, then go over here to the math button, click on math. We're going to scroll all the way over to PRB, probability. And then if we scroll down to number 4, we can see the exclamation mark, or factorial. Going to hit enter. We see our 3 factorial, and we hit enter again. And there is our 6 for our 6 ways. So a new concept is factorial, and it's written with an exclamation mark. And to put it into the calculator, you type in the number, math, PRB, factorial, or the exclamation mark, and hit enter, and that would give you the value. And that would be a great way to figure out letter A here, where a television news director has 8 news stories to present on the evening news. So there are 8, how many different ways are there to present the 8 stories? So 8 factorial, you could multiply 8 times 7 times 6 times 5, etc., all the way down to 1, or put it into your calculator, and you would get 40,320. However, if only 3 of the stories will be presented, how many different ways are there to present the lead, the second story, and the closing story? So in this case, we only want the first 3. So 8 times 7 times 6, which gives us 336. You might see this written as if we had 8 objects and we only want 3 of them. So we have an 8, our P, and then the 3. And notice the 8 and the 3 are sub. They're dropped down a little bit. So technically it's going to be written like this. So in blue, I'm showing you where the 8 times 7 times 6 came from. So in the numerator, we have 8 factorial, and then from the 8, we subtracted the 3 because we had the top 3 choices. That gave us 5 factorial. And then when I work it out, you can see that the 5s, 4s, 3s, 2s, and 1s cancel, and there's my 8 times 7 times 6, which gave us the 336. Before we continue on to our last example, make sure that you write down how to enter it into your calculator, what factorial is, and also the formula down here at the bottom of the slide. Okay, the last type you might see would be permutations with repetition. So make sure that you include this in your notes. So it might say distinguishable permutations of the letters in Miami. So there are 5 letters in Miami, so that's going to be 5 factorial in the numerator. And then we have repeating m's, so that's 2 factorial. And then we have repeating i's, so that's another 2 factorial. So 5 factorial comes out to 120 over 4, which gives us 30 possible ways. Tallahassee has 11 total letters, so 11 factorial. We have repeating A's, so that's 2 factorial. We have repeating L's, that's another 2 factorial. Oops, we have 3 A's. I need to change that. And then we have 2 S's, so 2 factorial, and 2 E's. When I multiply this all out, the 3 was 3 times 2 times 1, so that's where the 6 came from, and then 2 times 1, etc. If I divide our numerator by the denominator, it comes out to 831,600 ways.